Hey y'all, Elephant Justin here, screwing around as usual.
Hold on, I'm getting a call. Hello?
Hi Sammy, it's Mr. J. I'm very sick. I need you to come and see me at l'hôpital.
Oh no, what's wrong?
You see, I'm not feeling well. I think there is something wrong with the spirit of calculus. You need to gather all 6 parts of C.
We'll be right over.
So, here's a map. You have to travel to each one of those places in calculus land. At each location, you must answer a problem related to the region and then find the missing parts of C. Once you have found all 6 parts, give them to me. Then I will feel better. The first stop is the Sea of Solids. Go get some calculus.
Let's go, Sammy. Woo!
Now that we have the map, we have to find the Sea of Solids.
It is.
It's upside down.
It's not on the map, so we can't find it.
It's right there.
It's on the map right here, so we can find it.
So something told us that like the Sea of Solids would be somewhere near here. So let's take a look. Oh, look at that. What's that? Justin!
My fanny pack found it.
There's a volcano. There's solids in the sea. That's
Sea of Solids. Duh.
sea of solids. And see, look at that. Sea of solids / volcanic volumes.
I'm pointing out where we are with this magic scissors. These scissors are gonna help us find all the points of C. I can guarantee you that.
Really?
You're freaking crazy. They're never
We'll
gonna
see
help.
about that. So now that we are here, let's answer the question for Sea of Solids. So, what are you looking at?
Justin.
Justin? What's this?
Oh, I already solved the problem you guys were talking.
We were barely talking at all, and you were just over there a second ago.
What is it?
Turn our back for 2 seconds.
How did you already finish this?
Man, it was simple.
It's basically just a solid revolution thingy. So what you do is that you take area R, rotate it around y equals 8. This will give you some sort of weird device that looks like a volcano? Yes, something like a volcano actually. And then all you gotta do is figure out what the area big R is and what the area small R is, because what we know is that the volume of this weird volcano thingy is gonna be space times height, as all volumes are. Then we know that the base has to equal to pi times big R squared, boop, minus small r squared, boop. Then we just figure out what those values are. Big R squared is going to be 8 minus this line right here, which is actually defined in the problem as 4 ln 3 minus x. So you subtract these two and square the whole result. And the second part is that this distance, which is just 2, because it's 8 minus 6, which is 2. 2 squared is 4. You bada bing, bada boom, crunch the numbers, and you find that the answer is this guy right here. Alright.
So after solving this, apparently we need to find some part of C. Let's go find it then.
This is weird. Like, how are we gonna find part C? Do we even know what it looks like? Whoa, the scissors?
Wait, why did the scissors just go? Oh, I found it. The
Oh.
scissors must have helped us.
You were right.
Yes, I knew I was right. The scissors will help us. I'm looking at Sammy's face. Okay, we found the part of C. What's next? The map. No, there's nothing on it.
Flip it over.
Oh, there we go. So we have to go from the sea to Function Forest. All right, Function Forest, where we go. Let's go.
Let's go! So the function forest is like really rare and like it's dangerous and like it's kind of scary. Like the sun doesn't even shine to the ground. Stop laughing. It's true. See, look. This is where we have to go. The function forest. You can't even see it.
Freeze.
To forest. We already went to the Sea of Solids and we came from l'hôpital, so we're going to function forest. We forgot notebooks.
All right. We will crash your car.
She almost got hit by that car.
This is such a dangerous street. So I've lost your key fob.
That's fine.
No, I didn't. Take 2. We're going to the function forest. Okay? Okay?
Okay.
No,
Okay.
it's C.
Okay, now we're at function forest. Yeah, see, it's pretty dangerous, like I told you. Here's... So, we made it to the heart of Function Forest. It's really windy. Okay, let's get started with this problem. Okay, so now that we we completed the problem, we have to find the second part of C. Okay, so let's look around. This is tough, I don't know. Oh my gosh, you dropped the scissors.
Whoa, what's that? It's the
Part of C! Oh my god, wow, we got the second part of C! So now we have to go to the next place. So let's take a look at the map.
Stupid.
Okay, so we are leaving the dangerous Function Forest. Ah! There were even dinosaurs there. It's so scary. Okay, we had to touch one. Yeah, it almost ate us. So here's the map. We just left the Function Forest, and now we have to go to the Particle Palace. See that? Wait, come on, thing. Gotta go to the Particle Palace. Okay. So. So the thing about it is we have to be fast.
The reason why we gotta go fast to the Particle Palace is because the Mad King is extremely pissed off at people who are very smart. So we're not allowed to stay there for very long. We just gotta find the piece of C and dip.
Yep, we got
Like
it.
their fries.
You're spoiling it. We've arrived at the Particle Palace. You're now at the Particle Palace. See, there's royalty everywhere.
Like me.
Alright there, Kookaburra. We're in the shady places of Particle Palace, and my Australian ass just spelled it. Anyway, that's the problem. Right, so, the problem states that we have a particle. A particle moves along the x-axis. The velocity of the particle at time t is 6t minus t squared. What is the total distance traveled by the particle from time t equals 0 to t equals 3? So, how we do said problem is that we first need to understand that the area under the velocity curve is going to be the displacement of a particle. So, if I were to represent that, it'd be as such. However, this only represents the displacement. We want the total distance traveled. So in order to do that, we actually need to find the absolute value of the area under the curve of the velocity. The area of the absolute value version of the velocity. Sorry, excuse me. So, in order to do that, we have to find the integral of 6t minus t squared, but the absolute value version of it, dt. I forgot a dt here and here. Then, and we also want it from the times 0 to 3, so we do 0, 3. So now, we just integrate. Because the integral of 6t is going to be 6t squared over 2. And then the integral of t squared is going to be t cubed over 3. So now we gotta make sure to do is plug in a 3 and a 0. So we have 6, 3, 0, 2. We don't need the absolute value. Minus t 3 cubed over 3. Absolute value, because my partner over here does not wait till the last step. And then we find that we have 6 times 9 over 2. Cancel these out, that makes a 3. Minus 27 over 3, which is equal to 9. So we have a 27 minus 9, which equals 18. So the total distance traveled is 18. 18 units. It does not specify.
Okay, so now that we answered the problem, we just gotta find the C. Okay, do this.
Okay, let's look.
Uh-oh.
Oh, the scissors.
Oh, I found it!
Oh, you
The
found
scissors are the dividing rod.
Okay, we found it. Now we gotta get out of here.
Before the Mad King gets mad at
Okay,
us.
let's go. Oh my god! Snap! Why would you do that? I kind of stole the crown. Okay, where are we going?
Snap's a kleptomaniac.
Okay, so
All right, all my guys, gals, and non-binary pals. The next place we're gonna go is Integral Isle.
that was perfect. Okay, so as Justin said, we're going to Integral Isle. So
I need to hear something.
they are bickering, but we started at L'Hôpital. We went to the Sea of Solids. We went to the Function Forest. Then we went to the Particle Palace, and now we have to go to Integral Isle. We have arrived at Integral Isle. Wonder why it took us here. That's strange.
So like, why did it take us here? Let's check the map again.
Why is it not an island anymore? It's a literal store island.
You see the island in the back.
This is why.
You can see the island in the picture.
Shut up! Shut up! So maybe it wants us to find something island related in a store.
I found it. It says Maui. Hey, look. It says Maui.
Okay,
This is just
perfect.
find
We
everything.
found the place where we need.
Ew, no.
Hi.
Now we found the place where we need to answer the question.
So we lost Justin. He just like left. And so now we're gonna do his problem. So here's the thing. Okay, so this is the problem we have to do. Does it look familiar? I think it does. AP test 2? Ooh, this is illegal. Okay, anyway, so we have to do, since we're at Integral Isle, we have to do the integral from 1 to 3 of 3x minus 2dx. So, you have to find the antiderivative of 3x, which is 3x squared over 2 minus 2x. And then you do this, and then you do this, and then you do this, and you do this. Okay, now we evaluate each of these things. So this is 3 times 3 squared. 3 squared is 9 times 3. This one's for people. And then you do this. Hopefully I'm doing this right. And then it's 3 over 2. This is taking forever. And then you want to do some quick maths. Ooh, look at those quick maths. Yeah, it's already there. Whoa. Yeah, and then this one is the same as 3 over 2 minus 4 over 2, which is negative 1 over 2. So that means you're going to have plus, because this is a plus. You have 16 over 2. Right? And then it's 8. Bam. Bam. So who got it right on the AP test? It was answer C, I remember that. It was D. Oops, C was 6. Okay, now we just need to find part C.
Hold on a second. In addition to finding the fourth part of C, we need to find Justin. This was not planned. So, update. Still haven't found Justin. We literally don't know where he is. Justin! You wanted to look at books. Well, we just have to find part C now.
Also, this is what I found when looking at books.
Oh. Oh, do you like that?
This is an M. Of course I do. That is not slow. That is mediocre.
It's backwards.
I can't see your. Wait, I think you can press the ear.
What? Oh, they light up.
Where?
I think yours is broken.
You're just not as cool as me.
Sad days.
The beginning of December, because of how cold it's getting.
Sammy? So now the next part is to find C. So we're in the aquatic section with all the fish, but there are no fish right now. Okay, let's find the C. Okay, let's look. Let's look around. The scissors told you to do it. There it is.
It's a divining rod, guys. Snip, snip.
Okay, we found the part of C.
Stop backing into me. This is so soft.
Ooh.
Feel it.
Oh, it is soft. Oh. Yeah, they felt it too. It's pretty soft, right? Okay, now let's get out of here. So after the integral isle, we have to go to the derivative desert. Okay, so now we're on our way to find the fifth part of the sea. We are going to the derivative desert, which is literally anywhere in Ridgecrest. So we are going to venture to the top of B Mountain. Just kidding. Guys, we're going to the top of B Mountain.
Where's the B, huh?
It's right there! Yeah, it's right there!
There was the 19, huh?
It's right there!
So for this part of the video, the wind is super strong and you can't even hear what we're saying. So I'm just going to repeat what we said. So find the derivative of f when f of x equals 2x minus 1. So we were battling the wind, and then Sammy wrote the derivative of 2x minus 1 over dx equals. And obviously it equals 2, but we kept fiddling with the wind. I don't know what we were doing, and just bear with me for a second. This takes a while. And then 2, okay, awesome. And then we started to freak out because that's amazing.
Okay, now we found the answer to the problem, so let's find C. Let's do it.
Okay, let's look for it. Let's look for it. Whoa, the scissors! Whoa!
Oh, I found
Oh!
I can't get
Stuck. It's stuck.
No, we're good.
Woo! We got the part of C.
The dividing rod scissors helped us again.
Okay, so now that our hairs are thoroughly trashed.
Or mine's fixed, actually.
Okay, so we are now leaving the derivative desert and are going to related rates rapid. It's been a long day. Snoozing.
Don't hear me sleeping.
So, we have made it to related rates rapids, and oh no, the rapid is dried out.
A cylindrical barrel with a diameter of 2 feet contains collected rainwater. The water drains out through a valve at the bottom of the barrel. The rate of change of the height h of the water in the barrel with respect to time t is modeled by dh over dt equals negative 1/10 times the square root of h, where h is measured in feet and t is measured in seconds. The volume v of a cylinder of a height h and radius r is v equals pi r squared times h. Find the rate of the volume of the water in the barrel with respect to time when the height of water is 4 feet. Okay. So, we want... How do I do this myself? We want dv over dt when h equals 4. Okay. We know that v equals pi r squared times h. So dv over dt equals pi r squared times dh over dt. And then we plug in what we know. So pi equals 1 squared because the diameter is 2, so the radius is 1, times negative 1/10 times the square root of h, and h equals 4. So it's pi times negative 1 over 10 times the square root of 4 equals, equals negative 2 pi over 10 equals negative pi fifths. Woohoo!
Now that we answered the problem, it's time to find the part of C. So let's adjust it.
What? Over there.
Oh, the scissors told us where. There it is. We got it.
Scissors. Yay! We found all 6 pieces now.
We got the last part of C.
Okay.
Our journey through calculus land is almost complete. We just gotta go back through the Sea of Solids to save Mr. J.
Yep. And through the Sea of Solids, we'll be on our way to Lopizal. Woo. Yeah. Okay.
And our outfits will go back to normal, so be prepared for that. We did it! We did it! We did it! Yeah! Moisilo! We did it! Oh no! Alright, let's quickly assemble this sea. Integral isles, function forests, and Sea of Solids.
You know, you guys, I feel like this is wrong.
Oh,
What?
very right. See, look.
See? Look!
Okay.
See? Look!
We should have cut the duct tape before.
We have scissors right here! Yeah, we're duct taping. The sea. Dun, 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 dun. Do you want to reinforce it in the back now?
No.
Okay. We have C.
Mr. J,
we have the part of C.
what do we do now?
Give it to me. Give it to me. Oh, thank you. Thank you. You put them together. Thank you. I'm feeling better already.
We
saved calculus!
Woo!